Welcome back to the Deep Dive. Today we're getting into something really fascinating. We're sifting through some source material that we're calling the blueprints for the decentralized web. Our mission is to really decode this tension that defines the whole industry right now.
It's the big one.
Yeah, on one side you have these highly technical, almost architectural guides for Web3 developers. And on the other, you've got the practical nuts and bolts infrastructure that's connecting crypto to the traditional financial world.
And that tension is absolutely key. For you, the learner, this deep dive is all about connecting that, let's call it academic code, with the actual commercial outcome.
Right.
We're not just talking theory here. We're looking at the foundational steps you need to build dApps. And then right after that, we're analyzing the real-world utility, the ability to just spend your crypto instantly anywhere in the world.
Using things like Visa and MasterCard.
Exactly. The goal is to pull out the core concepts for you and show you exactly where the digital blueprints meet the actual physical road.
And that's our initial hook, that direct link. We've got sources laying out the developer's roadmap, the required tools, the curriculum, and right alongside that, operational data from a service like PintoPay, which is, they're actively turning crypto into spendable cash.
We're going from the diagram to the construction site.
Okay, let's start with the developers. We have these blueprints, and they outline this mandatory transition from Web 2 to Web 3. For a programmer, a seasoned one, what's the single biggest conceptual hurdle they have to clear right away?
It's the shift in the mechanism of trust. It really is. In Web 2, you trust a server, you trust the company running it.
The institution.
The institution, exactly. In Web 3, you have to trust the cryptographic proof that's baked right into the code. This reliance on blockchain fundamentals. It means you aren't just building an application, you're programming a ledger.
So the focus changes.
The focus shifts entirely. It's not about managing data in a database anymore. It's about managing state changes across a network that is, by design, immutable and distributed.
State change is crucial. That's the real difference, isn't it? Updating a server versus executing a confirmed final transaction on a chain.
Exactly. And when you execute a transaction, you have to think about things like finality. That moment, a transaction can't be reversed. And the costs, the gas fees, developers have to get their heads around the fact that every single change they program has an immediate, permanent, and often pretty costly real-world effect.
And the sources are really specific about the toolkit here. The main chain they're all building on is Ethereum. Why is Ethereum still positioned as the primary platform in these guides?
It's really maturity and network effect. I mean, it's been around, it's robust. Ethereum supports the kind of programmable logic you need for these complex dApps. And to program that logic, the actual rules of the application, you need a specialized language.
Which is Solidity.
It's designed for one thing, writing smart contracts. And the resources also highlight the local environments, the tools. They name Hardhat and Truffle specifically. These are more than just editors. They're crucial development frameworks. Hardhat, for example, lets you spin up a local Ethereum network on your own machine.
So you can test things out.
You can test everything rapidly, iteratively, before you deploy to the mainnet and start paying those real gas fees. It is the sandbox that prevents incredibly expensive mistakes.
That sequencing in the developer curriculum you mentioned, it makes total sense now. It's not just a random list. You have to start with the blockchain fundamentals, the core concepts of state and finality.
You have to.
Then you get the smart contracts, explain what they do functionally. After that, you move to the specific language, the introduction to Solidity, and only then do you get to the steps for building, deploying, and interacting with a dApp.
That sequence is absolutely deliberate. You have to understand the philosophy and the constraints of the contract before you write a single line of code. Because this is where it gets really interesting for you. The smart contract is the core logic. It dictates everything.
So if the contract is this self-executing agreement, what happens if there's a flaw? What do these blueprints say about that risk? I mean, if the code is immutable, who fixes a bug?
That's the tension at the heart of all of this, and it's why auditing is now such a huge industry. The core idea is immutability, yes. Once it's deployed, the rules just run. However, these same sources also talk about things like upgradability proxies or multi-signature wallets. If you design those in from the start, they can allow a decentralized group to intervene for critical fixes.
But you have to plan for it.
You have to have that foresight. If you build it to be truly permanently immutable and there's a flaw, that flaw is forever. And this self-executing logic is really why you, the learner, should care. This is the mechanism that removes the intermediaries, the banks, the lawyers, the escrow services. You're trusting math and cryptography, not an institution.
Okay, now we have to make the pivot. So these contracts generate value, currency, tokens, whatever. The next critical question is, how does that value get out of this decentralized loop and become usable in the physical world?
Right.
So we move from abstract Solidity code to the tangible financial layer, and we focus on Pinto Pay.
Pinto Pay is the perfect example of this bridge architecture that Web3 needs to actually thrive. They're focused on solving that one problem, liquidity and usability. Their goal is simple. Let people spend their crypto like it's cash, instantly, globally.
They're the off-ramp, and the sources explain how they do it. They integrate a crypto wallet directly into payment systems we already use and trust, things like Apple Pay and Google Pay, plus physical and virtual cards. And it's important to note, the whole thing relies on a secure neobank infrastructure and runs on the rails of Visa and MasterCard.
They're using the most stable parts of TradFi to make crypto useful. And this isn't some small pilot program. The metrics show real adoption. They report a total user count of 117,250.
Okay.
But what's more telling for you as the learner is the engagement. They have 38,000 monthly active users, MAU, and 12,500 daily active users, or DAU.
That's a high ratio.
A very high ratio. It shows the service isn't just being downloaded and forgotten. People are integrating it into their daily spending.
That daily usage metric is a really strong signal of utility over just speculation.
Yeah.
And the growth isn't just on the consumer side. They're expanding B2B, reporting over 11 new integrations per month. Other crypto projects want and need this infrastructure.
Absolutely.
So let's shift to that business side. If a project, a wallet, an exchange wants to integrate this for their own users, the sources describe two clear partnership models, and they really highlight the strategic trade-offs involved.
Yeah, this is a classic build versus buy scenario, just packaged for Web3. The first option is the API solution. This is for projects that are already highly technical. They already have their own fintech platform, their own wallets.
They just need the connection.
They just need the back end. The API solution is cheaper to start. It's priced at $9,500. For that, you get the API library, an admin dashboard, and L2 support.
And L2 is what exactly?
Level 2. It's the deep technical help for integration issues, system stability. It's not customer service for the end user, and that's the trade-off. You get technical control, lower cost, but you have to build your own front end. No custom branding, no client interface.
Okay, so you contrast that with the other option, the white label solution.
The white label is the turnkey option.
Oh.
It's for partners who want the solution ready to go, right out of the box with minimal work on their end.
And it costs more.
A lot more. It's a $30,500 investment. But for that, you get the full ecosystem. You get L1 and L2 support. And L1 is crucial. That's the direct customer service, handling user questions, card issues. You get custom branding, a complete built-in client interface, and even a Telegram mini app.
So it's for companies who value speed to market over that initial cost.
Exactly. Brand consistency and speed.
And the financial incentive here for partners is where this whole thing clicks. They're not just offering a service. They're generating a whole new revenue stream. They earn a commission on every card issued and every single time it's topped up.
And that stream is quantified really nicely in the source forecast. It gives us a concrete number. They project that if a partner has just 1,000 users and each one spends about $1,000 a month.
Which is not unreasonable.
Not at all for daily global spending. That generates $1 million in monthly volume. Based on their 1% to 2% commission, that partner is projected to make between $10,000 and $20,000 a month.
A 1% to 2% cut on that volume is significant. I mean, traditional card processors take similar amounts, but here, the partner is generating that revenue themselves while also making their own product stickier. It's a powerful model.
And we also see them actively trying to encourage that volume. The sources note some recent price adjustments. For instance, the card issuance fee was dropped dramatically.
From what to what?
From 25 USDT down to $12 USDT.
And just to clarify for you, the learner, USDT, is Tether, a stablecoin pegged to the US dollar. So they basically cut that cost in half.
More than half. And deposit fees have also come down, in some cases from 2% to 1.5%. These are strategic cuts designed to drive those high active user numbers we were just talking about. They're going for market share. So if we wrap all this up, the key takeaway is that the blueprints we started with, those Solidity guides, they aren't just academic. They lead directly to high utility tools. You can see the whole path from abstract code to instant crypto top-ups and global payments, all structured into these profitable, scalable business models.
So what does this all mean for you? You've seen the full stack. From the really complex permanent challenge of writing good Solidity code, all the way to the commercial reality of integrating with, the heavily regulated Visa and MasterCard networks. The decentralized web success is, well, it's completely interdependent. It needs both.
Deep technical building and seamless integration.
Exactly. So we've seen how to build a foundation of a dApp, and we've seen the financial machinery needed to make its output spendable. And this brings up a final provocative thought for you to think about, which is the harder challenge for the future of Web3 adoption. Convincing developers to master these new, difficult technical blueprints to build flawless, trustless tools, or convincing legacy financial systems to actually integrate them into the global economy.